Hello, BookTube. Welcome to another Your Daily Paper. Today's paper is the discovery of Suvorexant, the first orexin receptor drug for insomnia. This is a review paper talking about Suvorexant, which is it's quite a new drug. It is the first orexin antagonist to be approved by the FDA to be used as a insomnia treatment, and because it's a review article, review paper, it is quite long, and it starts talking about uh, the previous treatment for insomnia that we had, and most of these previous treatment were based on GABA, uh, GABA modulators, and GABA modulators are they work, they put you to sleep, but that is not real sleep. Like if you just take a crap load of benzodiazepines and you sleep for 52 hours, that is not real sleep. You're not going to wake up feeling refreshed. Your brain is not going to wake up with good memory consolidation as it should happen after good sleep. Non-REM GABA modulators like benzodiazepines, they alter the sleep architecture. They reduce non-REM sleep. They increase uh, daylight somnolence. They also reduce your cognitive ability. They reduce your memory ability. They reduce your motor ability. So, sorry, I just have something in my throat. GABA modulators are not good for sleep, but they are better than barbiturates, because barbiturates are just no. So the quest was, okay, we need to find a pharmacological treatment for insomnia. First, doesn't have all of these horrible side effects, and also doesn't cause addiction, because GABA modulators are extremely addictive, and they cause very very harsh withdrawing syndrome, and they also don't actually give you real sleep. So the question is, okay, let's try to find a pharmacological treatment to give people with insomnia real sleep, not just black them out. And that is Suvorexant, which is a orexin antagonist. Why did I read this paper today? Because Suvorexant is one of the drugs that I'm going to use during my PhD. We're going to use Suvorexant to try to minimize the side effects of another drug that we are testing. So we're testing. Sorry, I have two beautiful big boys, but they are quite uh, they can be somewhat yappy sometimes. They like making noises. The first one is a gigantic pit bull mix. He's like 40 kilos, and his name is Orion. The other one is like a pointer, a Portuguese pointer, I think, and his name is Ferdinand. Anyway, orexin antagonist. So Suvorexant is a competitive antagonist of both orexin receptors, orexin 1 and orexin 2. And the next part of this paper is good. It's not very long, but it's a good review of what orexins are. So what are orexins? Orexins are a population of neurons, the orexinergic neurons, that produce the orexin A and B neurotransmitters. These are neurons that only originate in the lateral hypothalamus. What is the lateral hypothalamus? Is by the side of the medial hypothalamus. Okay, if that helps you. They only originate there, but they project throughout the entire nervous system. Very wide projections. And orexins are one of the main factors in the lateral hypothalamus for the function of integrative physiology that the lateral hypothalamus has. And one of the things orexins do, these neurons do, is that they sustain. They are responsible for sustaining wakefulness. And today we know that narcoleptic patients, they have ablation of the orexin neurons. They don't have orexin. And if you cause, for example, in some animal models, if you cause the ablation of orexin, you will mimic the phenotype of narcolepsy. So orexins, these neurons in the lateral hypothalamus, are essential to keep you awake, to keep you conscious. There are two. They do a lot of things because they function as a integrative part. They integrate several parts of physiology, so they regulate. They're responsible for keeping you awake. They are responsible for controlling feeding. Orexins increase feeding. They are responsible for the hypercapnic ventilatory response, which is your breathing response. The breathing reflex that you have when there is an increase in CO2 in the atmosphere. They also help control pleasure behavior, like repetitive behavior, because orexins project to the reward system, to the nucleus accumbens. They do all of that. And the paper is a good review of that. Most important, what I liked the most about the review of orexins in this paper is that the paper focused on differentiating the functions of orexin A and orexin B, and orexin receptor 1 and orexin receptor 2. There is difference. For example, orexin receptor, they are yappy boys. Orexin receptor 1 seems to be more prominent in switching states of arousal. So going in the switching process between arousal and non-REM sleep, for example, that seems to be the main function of orexin receptor 1. But orexin receptor 2, the main function seems to be to maintain states of arousal. Orexin receptor 1 seems to be about a transition of states, and orexin receptor 2 about maintaining a state. I remember I was scratching my leg, having a leg scratch. Maybe it was a bug that got me in the leg, I don't know. Anyway, so yeah, orexin A and B, they come from the same pre-pro molecule. So because orexin is a peptide, so you have pre-pro orexin, which is synthesized, and then it is broken into two, orexin A and orexin B. If I remember correctly, orexin receptor 1 has a preference for orexin A. However, orexin receptor 2 binds to orexin A and B. So there is this distinction. The paper goes into details about that. One thing that I really like about this paper is that it goes into because this paper was written by the guys in the pharmaceutical company who came up with this drug. So the paper actually is written when the paper talks about the development, they talk about the first person. So like we here in this company, we tried this and this, and we came up with these strategies to get to this molecule. That was interesting. In the end of the paper, there is a conflict of interest in statement. They say we work in this company. Our objective was to develop a new pharmaceutical thing to make money for the company. They actually state that in the review. So yeah, and it was quite interesting too, because I'm not a chemist. I'm a chemist. I'm not a chemist. I'm not a biochemist. My major is biomedical sciences, and my master's is physiology. So I don't really do much like chemistry molecule, and they went into detail on how they got to this molecule was high throughput screening, high throughput screening is when you get like you test in series like thousands and thousands and thousands of molecules until you find one that kind of fits something you need. They did that, and they had a molecule that had some bad biophysical properties, so they tried to take this part of the molecule and put something else, and then they take this part of the molecule and put something else. And they tested it, and it's like, okay, there is this ring right in the middle of the molecule. I don't remember the name of the ring. It's a ring of atoms, like it forms a circle. And this ring is affecting the pharmacokinetics. The pharmacokinetics is basically how the drug runs through the body. Like pharmacokinetics is what the body does to the drug, and pharmacodynamics is what the body does to the drug does to the body. So like, okay, let's get, so if this ring is giving so many problems in the pharmacokinetics, let's get rid of this ring and put something else in the middle of the molecule. So they did that, and it worked. It was quite interesting to see this. They also go into the pharmacokinetics detail, like binding and rebinding constant of the molecules. When they started discussing it in the paper, there was an interesting thing that arose from the data they showed. Then, because the binding constant was different, was quite different from the unbinding constant. This pharmacokinetic capability could be actually useful to the administration of the drug in people. But then they say, okay, all of this only happens if you test the thing in room temperature, so like 21 degrees. And they tested it in 37 degrees, and all of that difference goes away. So all of the discussion, although interesting, does not apply to people, to animals who have to endothermic animals. And Suvorexant is the alternative to GABA modulators. GABA modulators are often allosteric modulators. They don't bind in the receptor where the endogenous molecule actually binds. They bind somewhere else in the receptor and facilitate the binding of the endogenous molecule. Suvorexant is a competitive agonist, is a competitive antagonist. So what is an antagonist? An antagonist is a drug that stops the functioning of a receptor. So what Suvorexant is doing is that it is stopping the orexin system from acting. And because orexins are very essential to maintain wakefulness, the theory is, okay, insomnia may be a dysfunction in the orexin system, and because your orexinergic system is hyperactivated, that's why you have insomnia. So let's give something to block the orexinergic system to help with insomnia. So they did that, and it works. It works quite well, and different from GABA modulators. Suvorexant actually gives you real sleep. It gives you real sleep, so it doesn't fuck up your sleep architecture like benzodiazepines do. But what got me in this paper is that it looks too good to be true. This drug is already approved by the FDA. It works. It is much better. There is substantial evidence that is extremely better than GABA modulators for insomnia. If you have insomnia, talk to your doctor about Suvorexant. I don't think that's the commercial name. The commercial name must be Belsona, alguma coisa, I don't know, something like that. But Suvorexant is the pharmacological name. It is much better than GABA modulators, but there must be some kind of collateral effect. There is no way. This is too good to be true. Way too good to be true. Like maybe the only reason why they didn't find some interesting of note collateral effects is because they didn't test it. As I said, orexins, they are a integrator of physiology, and they basically act on everything in your body. But maybe okay, they tested the basic sleep things like cognition, memory, etc., and different from GABA modulators, Suvorexant does not affect it. But maybe Suvorexant affects your appetite because orexins control feeding. Maybe it affects your reward system because orexins participate in modulating the nucleus accumbens. Maybe it affects your fight or flight response because orexins participate in the activation of the sympathetic nervous system. It's kind of indirect, but it does have a function. Maybe it alters your thermogenesis because the orexinergic system participates in thermogenesis, the generation of heat in the body. In the body, so something must happen. Something must happen. It's too good to be true. I just don't believe that there is no side effect, that no relevant side effect. There is no way. So quite a good review. I highly recommend. It's a thorough review. It's like 25 pages with small font, and there are some tables and some charts. But it's a thorough review. It's not the most thorough review I've ever read. I once read I once read. I don't think I've read the entire thing. I read some sub chapters of it. A review on the hypoxic ventilatory response that was like 120 pages long, a 120 page PDF with tiny font. I should read that. I should read that, all of that, but I haven't done it yet. And then you might be asking yourself, well, why are you interested in this orexin antagonist? I'm interested in it because my PhD is going to be first about the neurobiology of obstructive sleep apnea. That's what we are going to do. We have two objectives. We have the first objective is to complete the circuitry of melanocortin in the control of breathing in sleep apnea. So the melanocortin system participates in the control of breathing during sleep, and but we don't know the entire circuitry. It is not known from beginning to end where which neurons go from where to where and do what. The circuitry is like 80% complete. We need to finish. Finishing the understanding of this brain circuitry is part of my PhD. The other part is to discover a pharmacological treatment for obstructive sleep apnea. There is one drug that helps a lot, but the main side effect of this drug, I forgot the name of the drug, is SAT something. But the main side effect of this drug is that it causes sleep fragmentation. It disrupts your sleep architecture, which is kind of ironic. Like you're trying to fix apnea so people can sleep better, but the side effect is the disruption of the sleeping. And our hypothesis is that we can combine this drug, SAT, I forgot the entire name of the thing. We can combine SAT with Suvorexant to help sleep apnea, and through Suvorexant fix the sleep architecture. That is the intention. And we also we're not just going to test the drug. We need to understand how these two drugs, given concomitantly, work in the brain to control sleep and breathing during sleep. That's the second part of my PhD. So that's why I've read this paper. This paper was suggested to me by my supervisor. He was like, okay, we are going to use Suvorexant, so here's a review about Suvorexant from the guys who discovered it. And yeah, that was the paper for today. I hope it was useful for the 7 people around the world who care about this subject. And as you can see, second day in this channel, and I'm in a different place. This is our how do I say it? Collective office. There are five desks in this living room. It used to be a living room, now it's a office, and we all work here together, just like friends. Anyway, thank you, Booktube.